Okay, good morning, everybody, and super welcome to the blockchain governance module. And thank you, Nikos and Alicia, and the whole PBA team for having us again. It's our fourth time. It's the best time. And we're extra happy because we have both stakeholder groups in the room today, which is something that doesn't happen so often in structured forms, and we're really going to make the most out of it. I will just quickly introduce the whole module and us, and then Primavera will start with the introduction lecture. This is the kickoff meeting. So we're going to quickly go over what this is all about, why it matters, and what we want you to take home, and then some logistics. So this is a short backstory of the governance module. This is the second time we do it for both policymakers and developers. Originally, it was put in as kind of a political contextualization module for the devs to embed the technology in a wider societal context. But then it quite quickly moved on to being more of just governance, blockchain governance, and both on and off chain. So both this political embeddedness, but also the on-chain mechanisms that you need to know to be able to meaningfully interact with on-chain governance. It's a really huge topic, and we could spend a long time, but we only have half a day. So we're going to make it quite intense, but you're used to intense by now, so I don't think it's going to be a problem. For the policymakers, there's going to be a little bit of technical content, but you'll be able to follow along totally after the priming that you got from Filippo. So a quick intro of us. So there's 5 of us in the faculty. 2 of us are not here, but they have been here to provide the content and to teach on the previous PBA. So they are here as mentioned, so that you know that they have been involved. But us who are here today, it's me, Primavera, and Natalie. And my name is Lovisa. I'm the instigator of this module and the one that's making it happen together with Felix. And my background is in political science, but I got dropped into the Web3 space on the deep end, and then I found my footing in governance. And I think it's a huge interest. I think it's one of the most important topics, both objectively and also it's so politically relevant because institutions need upgrading in blockchain governance, and these decision-making systems that we're experimenting with is a really, really cool avenue to do this with. I joined Blockchain Gov, which is an ERC-funded research institute focused only on blockchain governance earlier this year, where the research director is Primavera. And please introduce yourself, and then Natalie.
Yeah, so I'm Primavera. I'm a legal scholar at the CNRS in Paris and at the Berkman Klein Center at Harvard. And it's been 11 years now that I'm focusing mostly all of my research on the legal challenges and the governance opportunities of blockchain technologies. And all the research is kind of trying to focus on both the how do blockchain communities organize themselves and what are the governance on-chain and off-chain that emerge out of that, but also how can the technology be adopted into more institutional frameworks. And then, of course, what are all the absolutely fascinating legal challenges that emerge out of this, and trying to kind of bridge between the blockchain world and between the more institutional legal world. And yeah, this is like the blockchain governance is like the main focus, and then I have sort of like artistic practice, and I'm also creating blockchain-based life forms that we can discuss later.
Oh, I'm Natalie. I have been working in public policy in the crypto space. Basically, that's a fancy word for lobbying and advocating for the technology with policymakers and governments, but also helping governments understand the technology. So basically bridging the needs of the industry and making it understood by policymakers so they can come up with legislation that actually makes sense with the technology. And yeah, that's the short version. I'm going to share more of that in the presentations.
Super. Easy. So we're all more or less connected to this research institute, Blockchain Gov, which is on its 5th year, and it's the final year this year. I put in this slide. I'm really unhappy with how it looks, but I just wanted to present that there's a lot of research and a lot of resources on the website that has been produced during Blockchain Gov over this last 5 years. There's a whole book on blockchain governance that Primavera co-authored with 2 other academics, and a lot of papers and cookbooks and so much material if you're interested to dive in. And this September, if you're in Paris, you can apply to join like a symposium that we have where we're going to present a lot of the research that has been done in the last 5 years and discuss it in depth. There's a link if you want. So quickly, what is this all about? So all blockchain projects have governance, even if it's either like implicit or explicit. And another way of saying this is that it's either conscious or unconscious, like it is there. There's always a decision-making structure and a governance structure in place, even though it's not necessarily explicitly designed. So one thing that has been shown is that if you have this explicitly designed, you have a huge advantage because you become much more resilient when things are changing. So to be as successful and like have as much longevity as possible as a project is something that you need to bear in mind when you're designing and when you're working in the space. And yeah, so we all have governance. Can read the points. I'm not going to read them out to you. It's what I just said, but in longer words. But it's still this very kind of under like not so well understood concept. So to start, we would like to have a short opinion poll. If you want to scan and just add your first association of what you hear about when you hear the word blockchain governance, we can get a little glance of where the room stands. Here, I can do this. This is not the one. I know here. Okay, actually, there's a lot.
Sergio.
Which one of you is Sergio? Yeah, but it is like it can be decentralized. It also cannot be, but in blockchain it's usually decentralized. Boring is is one that you actually often hear if you're not studying, if you're not geeking out about the political topics, but it's highly relevant, so it's definitely not boring. Taxes. Here we have to zoom in. Democratization, innovative, politics, security. Vox Populi, Vox Dei. So I'm gonna say this one. Thank you. But the takeaway from this exercise is always that it's really this term that's associated with so many topics and meanings and different interpretations, right? And we don't have a clear definition of what it is yet, because it is this nascent field that is evolving, that has influences from a lot of different academic avenues. So we have a lot of computer science, of course, because it's on-chain governance, a lot of it, but then there's also law, which Primavera has done extensive research on, political science, policy, cybernetics. It is this mixed beast. It's like a mixed political beast, which is in totally new form. And why does it matter? So it matters to all of you, but in slightly different ways. So depending on who you are, it depends. But you need to. So everyone has the importance. I lost my notes, I'm sorry. But it matters because it is a really it's been identified as the make or break quality of what makes blockchain projects be able to succeed long term, or what makes them not have the balance that they need to continue. And for developers, it varies a little bit. So it is it is not so well understood, but yet it's super important for the success of the project. There's a huge lack of technologies that are trained. And for Polkadot specifically, it is a highly decentralized system, and one of the most sophisticated governance systems that exist in the blockchain space. So to be able to work in the Polkadot ecosystem, you really need to be savvy in OpenGov and to understand why it's designed the way it is and the trade-offs that they put in there and why, right? Later today at 3, I think Filippo is giving you an OpenGov lecture, and also Max Rebol is giving another one focused on OpenGov at 5 p.m. So you will have some Polkadot specific content as well. And for policymakers, it's more important because it is this operating system of Web3. So it is the way that you can interact with the technology in a meaningful way. And as you are digitalized, like as all of our societies are digitalized, and we need this, and we want to have better infrastructure for it, and blockchain is this better infrastructure, but we need to be really well versed in how to understand and how to work it. And on a more zoomed out level, it is this testing ground for novel decision making. There's so much experimentation happening in the governance space on chain, and it will really be this thing that defines the future of how we govern the technology for sure, but also beyond. And I think maybe the most urgent is this, that if you have the expertise about what governance can do, you can also ensure that the technology is stewarded in the right direction and not veer off the path, so that it really is useful for public goods, right? And this is just to put in, it's a self-explanatory slide, but it shows you that it's a really important conversation to be having, because all of you are building societal infrastructure, and there's a lot of learning that you can do, and everybody wants it to be more resilient and to function better. So I'm just encouraging you to really lean in, especially in the afternoon when we're going to host a session together, to share as much as possible. And our educational goals is a very overarching one of just promoting governance literacy. So we want to equip you guys with the technologies. We really want to equip you with all of the competencies that you need to be able to design a governance system, and to see which trade-offs have been made and why they have been made, and to also be able to upgrade them if necessary. And for the policymakers, we want you to be able to approach it as this means of strengthening your current institutions. And overall, we just want to contribute to the professionalization of blockchain governance as a field of expertise. These are the learning outcomes. I think the key ones is 1, 2, and 5. 1, 2, 4, and 5, and 6. But to be the first one is the one we're going to do first, which is to understand that there are these different layers and dynamics of blockchain governance. So you have an institutional interface, and you also have a technical interface for the governance, and they both interact and merge and cross-learn a lot. Natalie is also going to hold a lecture on governance principles and mechanism design and progressive decentralization, because you don't necessarily want to have a governance system that's stagnant the whole time. You want to be able to evolve it over time, and you probably also want to have a roadmap for how you want to evolve that. And then number 5 is this very large gray area, which is that we want to help you to navigate the political, regulatory, and ethical implications of the system that is being built. And now some logistics, and then Primavera will give you the intro lecture. So this is today. We have Prima's lecture until 10 a.m. and then a break. Then we have 2 lectures by Natalie, I think with maybe a short stretcher in between. One about decentralized autonomous organizations and one about governance mechanism design. Then there's another short lecture on competency framework, so like how to increase the professionalization of the field. And then after lunch, we have a regulatory equivalence fishbowl and a small lecture as well. These are the schedules for tomorrow. The policymakers, you can take a photo if you want, but you can also just scan this and get the slides, and then you'll have it all there. And that's all. So after you have gotten the slides, I will leave the stage to Primavera, and thank you so much again, PBA, for having us. And yeah.
Okay, so this lecture is kind of like, it's designed for being appealing to both the policymaker and the engineers, which means that it's appealing to neither. So please feel absolutely free, and actually it is an invitation to do so. Please interrupt me at any point in time if you want to double click or zoom in into a particular topic or another, because like I think there are some topics that engineers are very acquainted with, but policymakers are not, and vice versa. So if you have like something that you hear that makes no sense, or that you want to hear more about, please ask a question, make a comment. So don't be afraid to interrupt. So justification, why are we here? And why is this course particularly important? Is because we are into a world that is increasingly being governed by technology. And therefore, the people that are building, but also the people that are controlling and also regulating this technology are the ones that are indirectly governing this world. So the issue is, of course, that the builders, the people that are actually building the technology, are not politicians, and vice versa, the politicians are not builders. So there's this kind of gap in between the two. Technologists are actually making a lot of design decisions, but the actors that are making the decision, on the one hand, are not elected through democratic mechanisms, so they don't have a representation of people that want a particular design, but also they are not trained to think about politics and governance, and this is what hopefully will change after this module. So this is a very common saying in political science, which is technology is neither good nor bad, but it is also not neutral. And that means that we can actually, by the design of the technology, there is always political values that are embedded and coded into these technologies. There's this very great book about, like, do artifacts have politics, which is essentially talking about how everything that we build around us has implications, has political, social implications, because of the affordance and the constraints that we create through those technological artifacts. And then there are a few examples from history. So this is like the low overpass bridges that were specifically designed in New York in order to actually prevent buses from driving through that street. And the political latent objective behind that was that they didn't want poor people that cannot afford a car to actually go into those neighborhoods. So by just creating an infrastructural constraints, then there is a full political action that comes, but it's not visible. It's not immediately understood as such. Another example in France is the Haussmannian boulevards, which were specifically designed to be extremely large, not just because of making Paris a very beautiful city, but also because the political intent was to make it very difficult for demonstration and protest to actually block the streets, because just making the streets so large makes it harder to actually block it. This is perhaps the most commonly experienced one. So the speed bumps. There can be a lot of laws and regulations that say you should not go faster than X. But there is also a technological tool that will break your car if you go faster than a particular speed. So it actually incentivizing people to slow down independently of what the law says, or independently if they want to respect it. So those are all examples in like physical architecture. But of course, when we move into digital architecture, we pretty much have exactly the same situation, where different designs of a particular digital artifact will have specific affordance, specific constraints, and of course, these also have important political implications. So Again, a few examples. I can choose what do I want to chat with. I can use WhatsApp, I can use Telegram, or I can use Signals. All of them serve the same function of enabling people to speak with one another, but of course, some of them have more decentralized or privacy compliant features. Similarly with like file storage, I can use Dropbox, which is controlled by a centralized system, or I can use BitTorrent, which has a more decentralized and therefore harder to censor situation. Equally speaking, between Tor, Freenet, etc. So we can actually design specific digital tools which are providing a function, but the design in which that function is being provided, of course, have very important implication on the usage and the users. And so, of course, blockchain do not escape that rule. Blockchain also have politics because they are digital artifacts. And so we can see also how different blockchain networks are specifically adopting a particular design, which will have specific implication from Bitcoin to Monero, which has a more privacy-oriented thing, Zcash similarly, and then Ethereum, which will also then add smart contract functionality in order to become this world computer, and then Polkadot with its own governance structure. So all those blockchains are providing similar function, but the design of the network has implication on the political context in which they operate. So now the question then is, like, as engineers, how to design those blockchain systems so that they provide that particular mix of affordance and constraints in order to actually fulfill the political agenda that comes behind. So that's like 101 introduction of why we need to care, because as engineers, we need to understand when we choose a particular technological design, what are the implications? And then as policymaker, we also need to understand how and whether to favor or to regulate or to limit specific designs because of the policy objectives. So now an important aspect when we're thinking about technological design is, of course, the question of trust and confidence. So blockchain technologies have been described since a long time as trustless technology, which the underlying idea is that we want to shift away from the need of trusting the people that we're interacting with, and instead, the only thing that we want to trust is mathematics and cryptography. And so we don't need to trust anymore because we have a system that enables to verify everything, and therefore we just eliminate the need of trust, and therefore we call it a trustless system. Now, the problem with this definition of trustless is that it defines what it is not, but it doesn't define what it is. So instead of a negative definition, a more positive definition of what a blockchain actually provides is that it is actually a confidence machine. It is actually providing confidence in the interaction that will be done through this infrastructure. So the idea is not necessarily to absolutely eliminate trust, but it's actually about increasing the degree of confidence so that we reduce the need. So if we think about trust and confidence, when you want to interact with a system or with people, there is always a particular degree of either trust or confidence that need to be fulfilled. If we are in a very, very low confidence environment, we will need a lot of trust to reach that particular degree in which we want to interact. If we have a lot of confidence, then we need a very little amount of trust. I don't need to trust you if I have confidence in the way in which the system works. And then there is everything in between. And so the blockchain is basically increasing confidence, and because it is increasing confidence, it is reducing the amount of trust that is required for people to choose to interact with one another, and therefore the possibility of transacting with pseudonymous and anonymous people. And so this confidence that the blockchain provides is basically emerging from a particular set of characteristics. On the one hand, there is everything related to the cryptographic primitives that make up the system. So if I understand and I believe and trust, or sorry, maybe not trust, I have confidence in the system of cryptography, mathematics, public, private key, cryptography, etc., I will be able to look at the blockchain and trust that everything I see is actually correct. And then in addition to that, it's not enough to just be able to verify. I also want to know that, independently of the verification, that there will be no one acting against my interest. And so in this case, there is all these economic incentives and game theories that are actually creating a particular utility function in which it is very likely that people are actually incentivized to act in a particular manner. And so again, this creates more confidence in the behavior of authors. So I need to trust them less because I know that their own personal incentive is aligned with mine. And then we have all this system of like expert systems. So maybe I don't myself know how to read the code in order to understand exactly how things work, but because of the verifiability and because of the code being open source, I trust the expert system to look at the code and to mention if something is wrong or not. And so by combining all those things, I, as an individual, I can feel assurance that whatever I will do on the blockchain will operate according to specific guarantees. And therefore, I don't need to know who's in front of me because I don't need to trust that person as much as I would otherwise. So this whole thing brings us to an important consequence, which we call the rule of code. So back in 1999, Lawrence Lessig, which is a very leader, pioneering academic from Harvard, has written this book, Code and Other Laws of Cyberspace, in which he claims that code is law. And with this claim, what he's saying is that increasingly, instead of relying on laws and regulations as a way of actually govern the behavior of people on the internet, we are increasingly moving to using code that actually dictates what can or cannot be done on the internet. And then, of course, the question is like, who controls that code? And can the law regulate the code that will then regulate the behavior of people? So now I'm entering a little bit into the legal space, so please forgive me. So in legal theory, we have this concept of the rule of law, which is basically that in a democratic society, in a non-authoritarian government, there are laws, and those laws apply equally to everyone. There is no discrimination on whether the law should apply or not. And that also applies to sovereign powers. That means that the law will dictate the rules, and no one can step on top of the law. Everyone will always be subject to the same rules, and even though, of course, the law can create distinction of categories. So this is like a basic condition of like how the law operates, which is no discrimination. This is to be opposed to other type of regimes which operate by the rule by law, where there is actually a shift between who is underneath the law and who is above the law, because you have a sovereign power that can actually instrumentalize the law, that is not subject to the law, and that has the power to change it as an instrument of power in order to actually express its own political power. And this is usually, we usually see this in like more authoritarian regimes that do not abide by the rule of law. So if we take those principles and then we map them into the digital internet world, we can create analogies. And so if we think about like the majority of online platforms that we interact with every day, they are actually ruled by code, meaning that there is a particular sovereign, which is the online operator that is managing this platform, which actually has the capacity to, at any moment, instrumentalize the code as a tool for its own political power or economic interest. And this leads to this kind of like digital feudalism, or like there's a lot of critics that comes into the fact that there is no democratic accountability in the way in which those platforms operate, because there is a unilateral sovereign that can just change at wish at any time the term of condition, the operation of the platform, because of course it is the landlord of this platform. And then we can contrast this with the concept of the rule of code, which is more applicable to blockchain system, in which, again, just like in the rule of law, no one is above the code, which means that developers can, of course, design a particular infrastructure, but once it is deployed, that code applies equally to everyone, of course, with the categorization distinction that can be made, but no one has the power to unilaterally modify the way in which the system works without following the rule of the code that were designed for this. So this means that when we enter into the rule of code, we can be much more confident that a system will operate in a particular manner, because no sovereign exists that can just come in and change the way in which the system operates. So as opposed to the rule by code, in which I need to trust, even if I have confidence in how the technology works, I need to trust the online operator not to change the technological design. In the context of a blockchain, I can have confidence that no matter what, I know exactly what are the rules, and those rules cannot be changed. So this is what justifies to regard the blockchain more as a confidence machine. Now, of course, as I said before, we can never fully eliminate trust, because even if the blockchain can increase confidence in the way things work, blockchain are not just technical systems, they are socio-technical systems. And so the confidence that we have in the technological artifact of a particular blockchain network actually depends on how much trust we have on the people that are operating this network. And while there is not one single sovereign, one single operator that can change things, there is a distributed consensus mechanism that can actually change things. And so the confidence in the on-chain blockchain-based rules depends on the trust in the off-chain processes that are running and maintaining this network. And so because of this very important component, this is why we cannot understand the technological guarantees of a blockchain system if we are not aware of the governance of that system, because the governance of the system, i.e. the on-chain and off-chain processes that exist, are the one that will determine how much confidence and how much trust we can have in this particular system. So blockchain governance is generally distinguished between governance by the infrastructure, so using the technology as a tool of governance, which is usually referred to as on-chain governance, and governance of the infrastructure, which is actually how is that infrastructure governed by people, and this is what we usually define as off-chain governance. So now we're gonna take a little deep dive into like who are the various actors that are engaged in either on-chain and off-chain governance, because those actors are actually the actors that we somehow have to trust in order to acquire confidence in the system. So the first category of actors are obviously the developers, but the core developers that really like manage the system at its core, and like all the system of like contributors that might contribute to the system. And so the governance of this particular category of actors is mostly of a technocratic governance, which is mostly like the people that are the most skilled will be the people that make the decisions. And this means that it will dictate like who actually have control over a particular repository, who can make changes in the repository. And of course, there is always this challenge, because a lot of the questions that developers have to make are oftentimes technical decisions. How do we fix a bug? How do we improve? How do we add features? But because of what I was explaining before, like every single one of those technical decisions are also political decisions, because they will have an impact. They will have a political impact on the operation of the network. And then, of course, it is important that those engineers, those developers that make decisions also have a proper understanding of those political implications. And this is particularly important in the case of like when those decisions cannot be agreed upon, which leads to like a split, a fork of the network, because of contentious issues that are not just objective technical, don't have a technical solution, but actually it's a political issue, and political issues do not have any objective solution, and that's where like that's where the problems emerge. Now, the second category of actors is the miners and the validators. So the people that are responsible for the production and the validation of blocks. And this type of actor operates through this kind of like distributed consensus mechanism, where there is some degree of potential plutocratic tendency, where like in a proof of work blockchain, the one that have the highest degree of hashing power might have more political power, or in a proof of stake, the one that have the most stake will have more political power. But also, this is countervailed with the individual nodes that will always have to validate those blocks. And so, even if a miner has a very large amount of hashing power, they cannot validate blocks that are invalid because they will be rejected by the network. And so there is this kind of like network governance in which, even though there are some actors that have potentially more power than others, they cannot cheat the rules of the system, because if they cheat, they will lose, because they will have invested either hashing power, or they will have lose their stake because the network will just not accept those blocks. So this is a way of like countervailing the potential plutocratic tendencies. Then we have the category of end users. So end users, which can be either just the people really using the system for the sake of the function, or all the token holders, of course, that maybe are just collecting tokens, and oftentimes user and token holders are also the same people. And so this one is actually quite clearly a plutocratic type of governance. Meaning that the more token one holds, then the more influence they have on the system. And this is basically creating a system in which the way in which you can voice yourself is by acquiring more token on the market. And the users that have little amount of tokens, they can still express themselves, but the only way of expressing themselves is by exiting the system, which still can create pressure, because of course, if everyone exits the system, the value of the tokens drops. And so the token holder will try to not make decisions that will push all the users away. And so again, there is this kind of like balance systems, even though it has a very strong type of plutocratic tendencies. And then of course, there is the problem of the whales, which have maybe too many tokens. But there is always, again, this attempt, at least in the design, that we don't want a few number of actors to have full control, and therefore creating system, in this case with economic systems, that there tries to be an alignment of incentive between the different type of users. Then another category are the intermediaries. So we have, of course, the mining pool or the staking pools, which are aggregating a lot of the decision-making power through like the validation of the production, the validation of the blocks. And then we also have the supernodes, which are basically actors that are not necessarily directly involved in the maintenance of the network, but that have a very important role. And this is, for instance, the case of cryptocurrencies exchange, blockchain explorers, custodian wallets, and so forth, which have a lot of users on their own platform. And so any decision that they make actually have a very strong implication, because all the users will automatically follow those decisions. And so, for instance, like if there is like a contentious fork and people are hesitating whether they go on one blockchain to another, if a large cryptocurrency exchange decides to endorse one side of the fork rather than the other, then everyone that is on that cryptocurrency exchange will also follow that chain, but also everyone who wants to transact with those people will also have to follow that chain. So they create a strong gravitational power towards users following their decisions. Same thing with like commercial service providers. So if Amazon were to say, I'm accepting funds from this side of a blockchain, then everyone that wants to benefit from the ability of using or interacting with the service provider will also have to through this chain. So the supernodes are really interesting because they actually have extreme amount of power, even though they actually don't touch directly the network in terms of block production or validation. And so the governance that emerged out of that is delegated governance. So we are delegating to those actors the power that the individual user have, which of course creates centralized points of failure and of control. And also these often create those kind of invisible power because it's unclear who has actually the power that has been delegated into, and yet they have like a strong influence on the network in particular because for the category of the supernodes. Then yet another category are the experts, which can be either the founders of specific project or the influencer, i.e. the people on social media that are very vocal about specific issues. And in this case, the governance is more of a meritocratic type of governance, because there is a sense that the individuals that are the most tech savvy might actually influence the public opinion. Of course, this is not necessarily the case on social media, in which it's not really tech savviness, but it's more like how loud can you be and how present can you be on the public sphere in order to actually try and influence the public opinion. But there's also like the founder generally hold a very strong influence in the governance of their own project, even though they don't necessarily have to even have actual power in terms of token. And then, yeah, the problem of like the social media being oftentimes distorted by people that maybe don't have that much tech savviness or influence, but they are speaking a lot, and therefore these actually influence people. And then finally, we have another important category, which are laws and regulators, policymakers and regulators. And those are actually like exogenous to the overarching the actual network, but they can have a strong influence by indirectly shaping and creating more or less risk into specific activities. So regulators can both act by legitimizing specific application or specific technological design, or by actually making some things illegal or making something like requiring a particular design in order to be legal, or another design will be illegal. And so while they don't affect directly the network, and they cannot actually affect directly the network, they can affect all those actors that I described before, which are in a particular jurisdiction and therefore will have to follow specific rules. But also they have the possibility of regulating directly the operation of the large intermediaries, which can be cryptocurrency exchange, mining and validating pools, etc. So as long as there is one big actor that is incorporated in a jurisdiction, they will be subject to those laws and regulations, which therefore indirectly will impact the network. So all those actors are, each one have their own typology of governance, and each one have their own capacity to influence the network in different ways, but they all play a role. And so this is a very important slide. The most important, okay, this is a very important slide. I suggest you pay attention to it or take a picture, which is basically trying to illustrate the polycentric governance system of a blockchain network, where we have, on the one hand, we have the technical layer, which is the network participants that are actually participating in the network, which are miner, validator, etc. On the other hand, we have the social layer, which are the developers, the influencers, the founders, the ones that are influencing the public opinion. And then we have the commercial operators, like the supernodes, the cryptocurrency exchange, the explorers, etc., which obviously have some kind of interaction between one and another. And then we have governments, which cannot really directly touch the network, but will find ways to influence either the social layer or the technical layer by trying to affect and regulate different actors. And then we have the users, which is unclear what their influence is on the network, but the user, of course, can join or leave the network as they wish, which also has an impact. And so it is this polycentric system. There is no single sovereign. There is no single operator that can do anything on the network, but it is this distributed network of actors, which are each exerting their own influence in order to influence the others, so that eventually there is this Schelling point that is found and this is the way in which the network will operate. So this is very important because this is showing the complexity, but this is also showing the power of the blockchain network, because it is precisely because it is decentralized in this polycentric manner that it does acquire these, well, that it does acquire the confidence that things are difficult to change, but of course that if trust is failing in any one of those points, then the rest of the system might try to adjust. But if trust is failing on many of those points, or if the shelling point is shifting, then the system might actually, the confidence in the system might break. So trust still exists, and all those actors need to be trusted for the confidence in the blockchain to actually emerge. So now we're gonna do like 2 case studies, and the objective of the case studies is to really like get a better grasp about the importance and the implication of blockchain governance. So who in the room is aware and knows the DAO story? Okay, it's a very beautiful story. I would suggest everyone to read as much as they can about it. The DAO was one of the first decentralized autonomous organizations, which Natalie will talk much more at length afterwards. And basically, it's like one particular typology of smart contract that was deployed on Ethereum. And the idea of this software was to be a decentralized investment fund. So what most DAOs are today, but that was like pretty much like the first one that acquired mainstream awareness. And so the idea was that people could invest into the DAO by putting it, and then they will get in exchange some DAO tokens. And then they could vote on specific project that will be funded by the DAO and get a return on investment on the result of those projects. So very basic, very standard, what many DAOs are doing today, but it was quite innovative at the time because it was the first one. So the idea was, of course, to create something that is autonomous, i.e. that doesn't have any specific leader in the management, and where all the rules of this organization are defined by the code of the smart contracts. And then this kind of like decentralized governance structure where the token holder are the shareholder, which are the one that make the decision. And then there was this kind of board of curator that will kind of like curate which proposal are valid or invalid before they can be voted upon. And of course, the idea was that this system is self-sufficient, which is it first with like a crowd sale, they will collect the funds necessarily for initiating the operation, and then through the investment, it will just feed back into the fund. So quite a standard and nice model for a DAO, except that, of course, it was early on, and mistakes happen, and so there was a bug. There was like a small vulnerability in the code that got identified after the DAO had already collected about $150 million. And then someone managed to take out of the DAO about $60 million worth of it, which doesn't sound that much today, but at the time it was a lot of it. So this obviously created very important discussions within the Ethereum community about how we should resolve this problem, whether we should do like a soft fork that will essentially just censor every transaction that is coming from or directed to this address, whether we should do a hard fork in order to then retrieve the funds and give them back to the original token holders. But of course, no one can choose to make a soft fork or a hard fork unilaterally. There is an important decision to be made through distributed consensus, which means that on the one hand, the miners have to agree, and of course also the verifiers. So this is a decision that cannot be made by anyone single-handed. So the question, of course, is that because no one can decide, the community is the only one that can choose whether or not to intervene. But intervention, while it is nice to take the money and give it back, it's also a very important violation of the blockchain protocol, which through its confidence machine does not allow for mutability or corruptibility. And here, because someone exploited a vulnerability, then the question is like, well, shall we actually now violate the protocol in order to resolve the problem? And so this created like a very important divide between the Ethereum community, between basically two camps. The one that says that we should always follow the words of the code, which means that the attacker that took the $60 million didn't really do anything wrong because the smart contract actually allowed for this, and it just happened that the smart contract was not well coded, but there was no violation of any rules or protocols. It was just actually just following the rule. And therefore, taking that money back and giving it to the token holder will actually be stealing from the attacker that just didn't do anything wrong but following the rules. On the other side of the camp, of course, there are the people that say, well, it's not about the wording of the code, it's about what the intention of the code was. What did the developer intended to do, and what did all the token holders that joined that system understood the system to do? And this is a very common distinction in contract law, where there is the wording of the contract and then there is the intention of the parties, and normally the judge will consider a little bit of both, but the most important one is the intention of the parties. And so this camp say that, well, actually the attacker has exploited a vulnerability that was therefore not a legitimate action, and therefore it will be completely legitimate to violate the rules of the protocol in order to take the money and give it back to the token holders. So very important debates that lasted not so much because there was also an urgency. There were only like a few days, like less than 1 month, to actually make the decision. Anyway, so the question again was the same. This was a bit different from the DAO hack because it happened a few months, so people were quite acquainted with the DAO hack. The difference is that the DAO hack was a decision that was extremely urgent because if the decision was not made between a particular period of time, the funds would be forever lost. In this case, the funds are still frozen. So the decision is still to be made potentially. But basically, there was a lot of time to think through. So there was not this same situation of urgency. There was more reflection possible. It was also no longer an exception because the DAO was an exception. Like it was like something we are doing once, we will never do again. But all of a sudden now it's the second time. It's hard to claim for exceptionality when it becomes recurrent. There was also no unfair enrichment, so no one was actually benefiting from that. There was no thief that benefit. And it was actually more contentious. It actually created, there's something wrong with the slides. It was more contentious because it required a particular discussion, which is no longer a discussion of, given the state of emergency, what's the best way to solve the problem? But it was actually, given that now we know that smart contracts are potentially buggy, and this is not something we can deny anymore because it's the second time. It's no longer a discussion of like, what do we do in this particular circumstance? But the conversation was more, are we gonna create a mechanism for actually like a procedure in order to deal with cases in which there is a problem, there is an issue that needs to be resolved, which basically require like a whole structure of like, I don't know who can make the decision about what, like what is the legitimate process, and most importantly, if we are to create such a, okay, perfect. If we are to create, if we are to create such a process, all of a sudden the whole narrative of immutability, confidence, etc., is kind of like pushed away because now we have a procedure in which some people whoever are the people that make decision in this procedure, will have a say of actually changing the rule of the protocol. And therefore, you never know. When you make a transaction, you never know if the transaction will be reverted because someone say, no, that was an unfair transaction. And so we're getting closer to contract law, as in the physical world, in which if you enter into a contract and the contract has some things that are not correct, you can revert it. In this case, it's kind of like shaking up a little bit the whole infrastructure of immutability. And then most interestingly, it also creates like the people that will make this decision. So if someone during the DAO hack had to say like, well, actually, I'm the one that decides, I think that's unfair, let's take the money back. All of a sudden, this person is actually potentially liable that the person from whom the funds have been taken away to sue the decision, the person that makes the decision that the funds should be taken away by saying, no, actually, you're stealing from me. And in fact, during this multi-sig problem, a lot of the EIP editors that actually make decision about what are the changes in the protocol that should be taken have actually quit because they realize that they are technicians and they are engineers and they can make and they are willing to make decisions on the technical objective things, but they didn't feel at all comfortable to make those kind of political decisions about whether we should modify the protocol and therefore modify the constraints and the affordance that come with it. So why it is interesting, those two cases, because both of those cases show that there are situations in which the rules of the protocol are not acting as expected. The DAO attack was clearly a state of exception. It was absolutely unexpected, and no one could ever think that there will be a bug in a smart contract. And it was a state of exception with no sovereign. There was like no possible entity to be identified that will be able to tell what's the right thing to do. But the community, as a distributed judiciary, has chosen that we should violate the rule of the code and therefore violate the immutability premise in order to restore that tort and actually provide back the funds to the token holder. The second one was no longer a state of exception. The second one was actually, if to be implemented, it was a legislative proposal. It was actually an amendment to the constitution of the Ethereum network that says, now we do actually create standardized procedure for the recovery of funds, which is a complete change in the actual constitutional framework of the blockchain, which is basically saying that immutability is no longer the most important value of the system, but rather justice and fairness, which obviously creates a lot of unpredictability and indeterminacy. And therefore, because of that, even though the technical solution was extremely simple and obvious what to do, it was decided that we didn't want to create this constitutional amendment. And so while a much more complicated situation with the DAO hack has actually led to an intervention, there has not been an intervention here, so they decided not to fork. Questions? Comments?
Can I have I have an anecdotal request. Sometimes you did this session with a bunch of judges.
Ah, yes. Yeah, so we did the DAO hack, like following the hack, well, after the fork, actually. We tried to make like a moot court. So we identified, like we found like 2 judges from the jurisdiction of Florida. And then we had like 2 lawyers, etc. And we had this moot court in which actually the developers were under attack. So someone that had lost the funds decided to sue the developers for negligence and many other things. And then the question was, then you had like the 2 lawyers that were arguing the various positions. And then we were asking those judges, which are real judges, to make a verdict. And like the moot court lasted like 3 hours or more. Like it was like a very intense conversation. And at the end, neither of the judges agreed to give a verdict. And it was 2017, so it was still early on. But basically they were like, we don't understand anything what's happening. if there is a bug in the software, why don't you fix it? And like, is the software still not fixed? You know, it's like, so it was like everything was so absurd for the judges that like they just could not. They could, like they say, we cannot come up with a verdict because we actually genuinely don't understand what you guys are talking about. So this showed that at least at that time, you know, even if someone would have wanted to sue the developers, the legal system was not ready at that time to even understand what we're talking about. And to be fair, it's like it requires a lot of like understanding of like what the system is in order to even make a decision, and at the time it was not possible. So this shows to, on the one hand, even if those judges had made a verdict anyhow, they will not have been able to do the intervention. So in some ways, like, it's actually interesting that no one has sued anyone. Like, we kind of knew who the developer was, no one has sued. And same thing with the multisig, no one has sued the developers, right? And mostly because you could sue them and you can put them to bankruptcy, but you will not restore your funds. And it's actually more practical to lobby the network so that the distributed consensus makes a decision for you, and so you can actually get the decision, because a legal decision will never have been enforced by the network anyways. And in fact, it was also an argument for this decision, is that if we do have specific actors which are responsible for making decisions about the standardized procedure for recovery, those people become the new point of failure that can then be pointed at by the regulator, and the regulator will say, now you make that decision. And so all of a sudden, because of this very important schematic, this one, you will see it soon, if you create this standard procedure for recovery, you're introducing a new actor, and this new actor is a human, and it's very easy to point and to regulate. And therefore, because now this entity has like so much power on the decision and on the influence of the network, this was like a very important, that was the reason why the EIP editor quit, because they were afraid that any decision they will make will be held against them from like a legal perspective. And secondly, it was also a decision why the network as a whole was like, no, actually, let's not do that. There is obviously, it's easy to do it, and there is many good reasons to do so, but then all of a sudden we're shaking the whole equilibrium of the blockchain, which will become too easily regulatable by touching those people.
Now the next session starts, and I'm going to take a few steps back. We've been already very deep into DAOs and DAO hacks, and I want to take 1 or 2 steps back and go a bit into the depth of what a DAO is, and then also what are different governance models of DAOs. So we can slowly approach, how would you do it? Or how would someone do it? And what are the differences, the trade-offs? That's what we're going to do today. So everything started with one question. And the question was, what if we could run an organization without managers or intermediaries, just by code and collective decision-making? So someone at some point had this question in mind. And that led eventually to the DAO. But what were the driving factors to get us there? So first of all, there was a distrust in traditional institution, but how did that come about? Generally speaking, I mean, eventually Bitcoin was invented, so that was out there, and then the financial crisis hit, 2008. That fed that mistrust a little bit. It was kind of another proof that centralized power can be abused, it can be corrupted, and if there's an intermediary with too much power, as the financial crisis once again showed, it's not a good idea. And that kind of led to a deeper ideological root, kind of rooted in the tech space and coming from the distrust, originated in the cyberpunk and the crypto-anarchist vision. And the idea was, what if we could have a system where you basically don't need to trust people, you trust mathematics, transparency, and code, and the collective will. basically. So no need for trust, no need to trust this one centralized banker that might be corrupted. And out of that, slowly, smart contracts evolved. Basically, the first automated agreements, very simple ones. And yeah, you could have an agreement between 2 or more parties, encode it, and it would be enacted, and you wouldn't need to trust much. Everything would be transparent. And once that was achieved, the next logical question was, well, if we can do this, then, you know, maybe what if we automate entire organizations with governance, with treasury, and with operations? Is that possible? And, you know, once you ask these questions, people get ideas. Maybe too many. So this is, and I'm not going to go through every little abbreviation here, but this is just Vitalik Buterin's first attempt in mapping out how humans have organized themselves over generations. Nuances matter. There is AI, there is this distinction. Does it manage internal capital? Doesn't it manage internal capital? Or is it automated organizations, self-automated organizations, and even organizations that have nothing to do with tech, right? A company that is just organized decentrally. So the point was like, in what kind of ways are we organizing ourselves and how can that evolve? And DAOs, at the center of this, were imagined as self-running entities. So code at the center and humans only at the edges. So that was the idea of a DAO. As you see, there's like a lot of nuance here, and forums, for example, like an organization with not managing any capital would be, for example, the G8 forum, right? So just to give you a taste. So coming from that, here's a little timeline and how we ended here. Thankfully, Primavera did a lot of the examples already, so I don't have to go to excruciating details, but the first time decentralized organization theory came up was already in the 60s and 70s, but that had very little to do with tech at the time. It was more like a management approach, like how can you organize governments or companies, corporations. And then this evolved, the term or the idea of decentralization. And the next thing we know, we were talking about in the 90s about DAOs as multi-agent Internet of Things systems. I think that's also very up to date again with AI coming. But back then we were thinking, could, for example, traffic lights coordinate with each other according to traffic and just organize in a way that, yeah, they turn green when it's best or red. And then, you know, we have smart devices at home. So that was already discussed as early as in the 90s. And then fast forward, Bitcoin came and the financial crisis came. We know the mistrust that came with that, and it sparked more and more thoughts. And then by 2013, we had several already, a lot of terminology trying to describe a decentralized organization or decentralized autonomous corporation. Back then, the idea was maybe you can pay dividends and have a share in this type of organization. Very soon after, though, they realized maybe this term is also not, is maybe too limiting, maybe we need another term. And then incidents like, yeah. And then eventually the slide that we saw before, Vitalik Buterin came up with this mapping because there were so many different abbreviations and ways to define it. And came up with the idea, maybe we should have the DAO experiment that we heard about, and which ultimately led to the DAO hack and a lot of lessons learned. That was not the end of the DAO, though. That was just the beginning, and it sparked a lot of, yeah, it motivated a lot of people to do the same, but better. And fast forward, we're in 2016, the DAO renaissance comes. So the idea of DAOs as a service, as infrastructure was born, and many projects tried their hand at creating the perfect improved DAO, which a lot of these projects still around, Aragon, Polkadot, DAO House. And yeah, this is where we are almost today. And then briefly after, decentralized finance came up, and they were like, hey, we should also have decentralized governance and some sort of organization for that kind of concept. And yeah, up until today, it has become more and more mainstream. We've learned a lot, painfully, but this is where we're at. This was the very, very, in a nutshell, summary of how we got here. But I will, and there's probably many definitions, but I want to leave you with this one, actually from Primavera, sitting down there. A DAO is a blockchain-based system that enables people to coordinate and govern themselves, mediated by a set of self-executing rules deployed on a public blockchain, and whose governance is decentralized. So this is, I think, at the core of understanding what every DAO does, like the, I think, best definition that you should maybe keep as a reference. So the main defining characteristic of a DAO is how people coordinate. It's describing, you know, a way of being and organizing, and it's not a purpose in itself. So you can't talk about a DAO, a decentralized autonomous organization, without deep diving a little bit in the term decentralization. And that's mainly the most, I guess, debated word in the whole industry. And not only from the tech perspective, but also regulators and politicians. Everybody's discussing what that means in their kind of scope, right? So on the one hand, we have the tech point of view, asking questions like, how's the architecture built? How many physical computers and nodes make up a system, and can this system keep running if some of them are shut down? So yeah, the more decentralized, it's like diversifying risk. That's a good thing, right? And that would be the definition. And the Nakamoto coefficient would try to measure that, right? The more entities it takes to control in order to have control over a system, the better, the more decentralized. The political definition is more about redistribution of authority and governance, right? So how centralized is a political system? Is it an autocracy? Is like one autocrat ruling it all, or is it a state system with municipalities and local assemblies that have been elected? And you can also think of decentralization in that manner, right? How do you organize? How's the governance organized? And then there is a regulatory definition. Regulators love to ask about who controls, who has liability, who has the risk. When it comes to digital asset, who protects the consumer. I took a definition as an example from the FIT21 Act in the US. A system is decentralized if no person has unilateral authority, no issuer owns more than 20% of tokens. We can discuss if that makes sense on a technical level. And governance is community-based. So that's like the basic they could kind of come up with. The 20% actually comes from shareholder and corporate law and finance law. Basically, like this is what you would probably need there to have substantial influence on a publicly listed company. In tech, I mean, we know in blockchain we would need a bit more to have control over a blockchain, but regulators have their own logic. And sometimes it's hard to kind of debate with them the logic, and a lot of things play into that. So yeah, this is a bit the three different ways to approach it. And I will say governance has piggybacked on all three of them when it comes to governance, the tech aspect, but also having to interact as a DAO with the real world, right? You have to consider that too. And then there are three kind of aspects to consider that kind of describe the nature of a DAO, right? So, I mean, or non-DAO, like centralized is not a DAO, but a centralized system would be a central node having the full control. And as you see, like if that falls out, then yeah, nothing would work. So that's a single point of failure. And then there's being decentralized. You have multiple important nodes, so no single point of control, already much better. If one fails, there's still some others to cover, but it also is still a bit of centered control, you know, distributed to certain anchor points. And then there is the ideal, the distributed system, where everybody, all nodes are equal and redundant. And the question here is, does that really like fully, truly exist? And I think it's a spectrum. Perfect distribution doesn't exist, especially as we have governance and systems to coordinate and organize ourselves. Because someone, we get there later, don't want to go too far ahead, but yeah, keep the question in mind, does it even exist, like perfect distribution, perfect equality between everybody in a system like that? Or are there trade-offs to be made? So this is what we refer to when we talk about distributed, decentralized, or centralized. Bottom line, decentralization is a spectrum. There's no one definition. There's different ways to approach it, and different point of views of people that will claim it to be a bit different, slightly different. So I'm gonna dump this on you now. And I try to not go into excruciating detail, because I think what I want you to take away from this, and I will go one by one through the examples, is different functions, different use cases have different approaches to governance and different difficulties to master. And that comes with trade-offs, which is the next presentation. But just to have a little glimpse of it or an idea. So I can read this font with my bad eyes. So we have OpenGov, Polkadot. Basically, the function here or the use case is infrastructure governing a blockchain ecosystem. How many eligible members do we have? Over 1 million dot holders, but how many are actually participating in the voting? Approximately 5,000 to 8,000, which is relatively high compared to other blockchains. So how complex is the system comparably? And what is like the key tension here? So it's pretty complex. So Polkadot is one of the more complex systems. You have multi-layer referenda, so there are parallel tracks of referenda happening at the same time. There's different ways to vote. You can delegate your vote to an expert. You can have conviction voting. So there's a lot of complexity, which also means there's a hurdle for newcomers, right? You really have to want to participate and learn all these rules. And that's probably not for the average Joe that is maybe a bit curious, but not heavily, involved, doesn't impact his life. Will probably not sit down unless he's really, really interested, like some people here. And then we have Uniswap. So yeah, what high complexity also means a voter apathy, right? If it's complex, maybe I'm less motivated to participate, and that's a downside. Uniswap, it's a financial app, different use case, 360K, Uni token around, 1 to 2,000 actively voting and participating. And here in this system, we have a significant power asymmetry among token holders, and that's kind of rooted in its structure and the way they're handling it. So the complexity is medium. It's a bit more deterministic. You have 1 token equals 1 vote, which is the same in Polkadot, but Polkadot has a lot of layers and complexity, which tries to distribute distribute the power dynamics a bit more. So Uniswap has a lot of whales, and if you have a lot of token, that means a lot of power, and it has very high thresholds in basically getting legislation through, or not legislation, it's maybe too political, proposals is the better word. And therefore, it's hard to change something unless you have a lot of power in terms of token. And with that power, SECs or financial market authorities will ask questions, because that could mean unilateral control. Like if a few big whales or token hot wallets have that much decisive power, that raises questions about the independence of that DAO. And then we have Decentraland, a game, completely different use case again. They're using that, 200,000 users, but very like 100 to 300 actively voting. Also high complexity, you can apparently vote a lot of things in there. I'm not a gamer, so quoting here. Mix of tokens, land votes, very broad scope of decision-making opportunities there, which probably brings a lot of complexity, and therefore threshold to participate. So that again leads to concentrated voting power and apathy. Less people vote, the few that do vote also get to have more power. And then there's friends with benefit. This is actually like a social club. This is very community-centric. You get in with, if you have the same values, you're vetted by other users, a completely different setup. And the question is, how scalable is it, right? The complexity very low, lighter governance, but the community-driven aspect brings other complexities to it. Let's look a little bit deeper. I already maybe shared too many details. Example, Polkadot OpenGov. I mentioned already a few of the core like governance aspects and how they're dealing with it. You have on-chain OpenGov, that's their governance system and rules, basically. All proposals and votes are recorded transparently, so they're very community-focused. You have parallel tracks for the treasury, for technical proposals, and so on, and different like treasury bounties. So you can have multiple tracks at the same time happening. And then not everybody maybe has technical knowledge and they like to participate still, but they maybe don't know how to vote on a technical issue. So they can delegate their vote to an expert they trust. This is a distribution of power. So it's not as equal, but I keep a little bit of my power and my influence, but I can, distribute it to an expert, which kind of has collected a little bit more power because of the trust people give him. So that's a little bit of a trade-off, right? You lose a little bit of distribution for convenience. Yeah. And then there's conviction voting. So you can boost your vote's weight by locking your tokens for a longer time. So if you don't have 1 million tokens, but you really care about a topic, that can give you a bit more leverage. And it also enforces long-term thinking, right? You have to lock tokens so you can increase your voting power up to 6 times. But in the meantime, it's a commitment. In that time, you locked your tokens, you can't do anything else with them. So it's an opportunity for smaller people, like community members, to participate, have a strong stance. And it's also incentivizing skin in the game and long-term thinking, in a way, because you're kind of committed for the time locking your tokens on the blockchain. And of course, there's also something like a technical fellowship. So anyone can apply to be a member in there if you have a good reputation, if you're super good in tech questions and you'd like to maybe have people delegate their votes to you, or you want to fix problems that occur. This is, how you say, a fellowship. The idea is if there is a bug and you need someone to act fast, because if you're just like very democratic and you want everybody to participate, the trade-off here is time. It takes time for everybody to vote. Sometimes there's an emergency, right? We had examples before. There's a bug, you have to act. There's like assets at risks. There's someone potentially abusing the bug. In order to prevent that, there's a committee voted by the members that has the power to act faster. But they're also trusted by the community. So these are all lessons learned from former problems we faced, right? And implementations to solve that. But they're also always trade-offs. Being very democratic or centralizing a little bit of the power in the hands of a few chosen tech experts that can act faster in an emergency. Trade-offs, right? Strengths and weaknesses, all proposals originated, are proposed by the public, the community. They get to propose changes. They're part of it. It's like a very community-centric point of view. The multi-track model increased the votes by almost 2,000% within 6 months. So apparently that's something good. And it increased participation and probably motivated a lot of people. And then conviction voting also aligns with long-term incentives and motivates people. The weaknesses is it's still a very complex system. So you really need to be motivated to participate and have like a personal incentive, I guess. Yeah, so that means limited participation beyond very technical insiders. And yeah, a risk of voter fatigue. So takeaway, Polkadot governance, the most technical advanced one. They've thought of many, many different ways to make it equal, give equal voting powers, and therefore also very complex and least accessible to the wider
public. Question is, it's an infrastructure. Do end users need to be that active, or should it be projects building on top? That question to be maybe debated. Then DAOs is a means to govern financial applications, Uniswap. So Uniswap's approach to voting is a bit different. Say they have a 3-step governance process. So first, there's a request for comments. So they will initiate an idea, someone will post it in a forum, there will be community calls, people will discuss first and gather information, informal feedback that signals interest. Once that's done, there will be an off-chain vote. Snapshot, I always want to say Snapchat, but snapshot. So Snapshot is this off-chain platform that is kind of, you can outsource some of your voting activities there. It doesn't cost you gas fees as in transaction fees. So it's cheap, it's convenient, it's independent, they have a good system. And yeah, a lot of blockchains divert to using it, but it is off-chain. So the question remains, how do you enact it on-chain? But Uniswap, in this case, they use it as some sort of proof of interest, is a poll, it's not binding. And once this off-chain interest, like gasless free poll, has been successful, meaning the sentiment has proven 25K worth of uni has been moved forward this specific request. That's a positive sign in sentiment, and that means this project and a request can move forward to actively be voted upon. So that's a positive sign. If that happens, and that can happen by people delegating their token to whoever is requesting a change, and if they agree, they delegate, because you need a lot of, the threshold is high. I mean, who has 25,000 unis just to do it? A few whales, but everybody else needs delegated tokens to get there, or maybe collectives or coordination, and maybe internal lobbying with other participants that are active. So once that is achieved, it goes on chain. There will be a formal proposal submitted on the Ethereum blockchain, and herefore you need 10 million uni token, delegated or collected one way or another. Very high threshold, and the question remains, how accessible is it really? And it only passes if you get in total 40 million. And the big criticism here, I mean, the strength is it's less, I mean, it's not so complex like Polkadot, it's very straightforward. You have the branding and the name Uniswap is very credible. They have a lot of liquidity, so that also builds trust. And on the other side, and it's transparent, it's also good. On the other side, we have these high thresholds, and we have very few big whales. A16Z, a VC in the crypto space is known, one of them. And there has been a lot of criticism of them basically unilaterally dominating most of the votes. Is that a fail, constructual fail, to be discussed? But the idea is it's a rather deterministic system, code is law. I mean, there is some flexibility, but very high thresholds, but also more simple. Yeah, so basically that's the weakness. Yeah, and therefore also maybe lower participation and whale dominance. Yeah, okay. Then we have the gaming example, decentralized. So they're going for a hybrid model a little bit. So they do have also Snapshot, using it off-chain for off-chain voting. And they're enacting it on-chain in Aragon. So once there has been a preliminary vote, which is technically not binding on Snapshot, there has to be someone implementing and setting it off on the blockchain. So there is a human or a group of people with a certain amount of power, maybe delegated power, with a multi-signature wallet that have to actually take that vote and enact it and kick it off on the blockchain in Aragon. So this is a trade-off, right? So either you build your own governance or you don't, but voting costs gas fees. you have to have at least a trusted group of people then enacting it. So that's a trade-off here. In this case, there's also a DAO committee. Yeah, that's the one, the multi-signature that enacts the past proposals. And then there is a security advisory board overseeing the committee. So initially there was people from the project. By now they are voted by the community and elected. So there is some sort of balance of power or attempted balance of power. But again, it's not fully distributed, right? There is centers of power, either elected or one way or another, but you need still some sort of centralization. So the idea that DAOs are fully automated is wrong. I mean, as we're going into the governance topics, we're realizing you can't have a fully automated DAO without human intervention. There's so many aspects where you still need someone to sign off, someone to control, someone to maybe interfere. So it is not eliminating the human aspect of it, is just redistributing it and reorganizing it in a different manner in that context. So that's maybe important to consider. So yeah, all these governance models still one way or another needed. And even Bitcoin, we saw that the most, actually a project never intended to be interfered with. There was a workaround eventually when a problem occurred. And yeah, miners came together and validators came together to make a choice. So the perfect system that does run without any human intervention doesn't exist. Okay, back to Decentraland. So strength. So the full binding vote here happens on Snapshot. You need someone to enact it on the blockchain actively. If this group of people were to ignore that, technically, I mean, Snapshot is not binding. You could ignore it or delay it or whatever. So you really have to trust the elected people. Yeah. I said that already, sorry. Yeah. They're really good at clear community communication and forums. They have specialized committees that focus on specific topics with like expert view that are also trusted. So it's a kind of a flexible hybrid model where you have a lot of encoded rules, but also a lot of human aspect and like committees having expert knowledge and a little bit more power. So the takeaways here, you have an innovative design, but it's kind of aiming for decentralization by also still relying on committees. So again, they found this kind of balance for themselves. Again, all trade-offs. You will hear the word trade-offs a lot today from me. Right. So DAOs as a social club, the last, this is the microphone, sorry. The last example, so the social club. This is a bit different, Friends with Benefits. This is more like an online Soho club, right? You get in by recommendation, it's curated, who gets to get in. Of course, you have to also buy tokens, but there is a cultural fit. Do you have the same values? So there is a lot of humans having to kind of collectively make decisions on other members, right? So that's fine, as long as it's a smaller DAO, but the bigger it gets, the trickier it gets with organizing that. So this is, I guess, already the biggest problem here. They have committees and squads, small working groups that manage things like events, partnerships. There's a lot of community. It's very community-centric, and that's also the charms of it or the vibe of it. So it's culture first. The strengths are obviously the community and the identity. And they're kind of pioneering the DAO to company ownership model, meaning they have created also like a legal wrapper to act with the external world. So they're kind of trying this hybrid thing where they have some sort of legality in the real world to act. They have committees with a human factor, but they also have encoded some of the processes of membership on the DAO. So they're experimenting with how DAO can evolve into a sustainable business. And they're one of the first to explore these hybrid structures, combining on-chain governance with legal wrappers and operational teams. So yeah, but as this project scales, it's harder and harder to not have power clusters develop. Because eventually you have to delegate power to some groups to make some decisions for other people, especially if it's community-based and value-based. So you must be an approved member by the others. So different concept, different problems. So this leads also to the questions DAOs have to act with and interact with the real world. You cannot, even if you ignore the real world will deal with you. So you'd rather come up with an idea to interact with it. And these can be small problems. You want to sponsor a football team, they might not be able to receive your token because you're not a real entity, right? So these are like day-to-day interactions. So you need some sort of wrapper. Luckily, there is already some. So in Wyoming, in the US, they have come up with a DAO LLC to deal with that and to allow for DAOs to interact as a sort of organization. But unfortunately, they're only limited and tied to Wyoming, which is one jurisdiction in the US, not the whole USA. It's a lot of lawyer paperwork, heavy, not easily accessible, and probably expensive. I assume lawyers in the US. Yeah, but it's a first for the US. And then we have Switzerland and the Cayman and Panama coming up with a foundation system that was, I guess, broadly adopted by many DAOs, basically enabling them to act off-chain, but also the criticism is that is some sort of centralization still. There is an organization hiring, banking, maybe making executive decisions. There is some sort of advisory board that has also execution powers. So you can discuss how decentralized it is, but on the other hand, in the real world, you have to be able to interact too. So DAOs, depending on their use case, have to be designed to fit their function, but also regulatory requirements. That's kind of the takeaway. So it requires a combination of context-dependent on-chain and off-chain governance design. And in the next lecture, we will talk about these trade-offs a bit more in detail, what that means in implementation. Like if you opt for extreme immutability, what do you have to think of? Are there mechanisms you should have? Whereas, what are other examples of blockchains, how they like implemented that or dealt with it? So we talked a lot about already different kinds of DAOs and use cases and problems they have to solve in their governance, depending on their situation, complexities. Now we're getting a bit more practical. Basically, I'm going to talk a lot about food as a metaphor and recipes, and hope it's going to be more interesting. So the idea is designing blockchain governance is like creating the perfect recipe. It's like finding what works best for your case and debating the trade-offs you have to make in your specific case and understanding really what those trade-offs are. First of all, I want to say I'm basing this on, oh shit, I should stop hitting my microphone. I'm basing this on a paper also co-authored by Primavera, and I'm very entrusted by representing this, and I have this responsibility now and feel the pressure. And towards the end, she has, I don't want to deprive you of her knowledge in this specific topic, so towards the end, I will bring her on stage, so you can also ask her, and she can, I'm sure she has something to add, also do that. So I'm going to do my best representing these trade-offs, and then in the end bring in Primavera for that. So back to blockchain governance. Creating the perfect recipe in that. It's basically asking, like, what's your favorite meal? If I ask all of you, I will get 150, I don't know, how many people are we? Whatever, 150 different answers, right? Oh, it should be a bit more salt, a bit more spice, a bit more this. We have many different tastes, many different backgrounds, many different ideas of how it should be. And this is the same with blockchain governance. You will, like, I mean, if you look around, there's so many different ways DAOs Like not all DAOs are the same. Actually, every single one is slightly different. Because people were sitting, discussing, making like, oh, this is more important to us, this fits us. There's no one shoe fits all, or whatever glove. So yeah, I made that analogy already, but you will have to get used to it. So we will talk about different mechanisms that can create different experiences and ways to govern. And I will start off just with a recommendation. The Mechanism Institute, you should check it out. It's a library. They collect different kinds of on-chain mechanisms. It's a good overview to look at. Yeah. So there's different trade-offs. And mechanisms affect different aspects of governance design. Then generally speaking, we're having like process mechanisms and product mechanisms. Process mechanisms are more the how of governance, right? So what kind of voting procedures do you have? And who can propose? And what kind of quorum is needed? And is there any appeal timelines or delays? Or these are all kind of how to governance like decisions and how to create a process. And this can lead to product mechanisms. That's more the what that gets built and implemented. So the smart contract logic. And this is kind of, it can derive from the process mechanism. It can be also reversed if you have a very immutable blockchain that hinders changes in the process, right? And you can't properly change it easily because of the code, or you need very high thresholds to change something. So it can impact each other. Yeah. Having said this, there are 6 different types of flavors or things you have to balance. We will go through them one by one. Yeah. So we have on the one hand expediency. Basically, expediency describes the speed and the efficiency and having something at a low, fast, efficient cost. And the trade-off is participation. So either you have a lot of participation, you're very democratic, but that also takes time, to involve everybody, and that slows you down. So here's the trade-off: either you're super fast and efficient, or you're super inclusive. Then there's immutability versus adaptability. So either you are very binary, you have like code and you can barely change it, like tamper-proof transactions, censorship, resistance, all these benefits that you also want to have. Yeah, and the smart contract logic is enforced either way. So if you want to have this kind of strength in it, then you're immutable. But also, you lose adaptability. And we've seen there's a lot of problems that come. Not all of them are foreseeable. Maybe you want to leave a little bit of adaptability in there to change stuff, or maybe some backdoors, some mechanisms that allow for that. And there's a spectrum, right? You don't have to be on one end of these trade-offs. There's a middle way. There's different ways to do that. Yeah, for example, if you need to fix a bug, you're happy if you have the option to still adapt your system. And then there's determinism and discretion. So determinism is kind of, yeah, how clear are the rules encoded upfront? And it's basically if then something will be executed deterministically. So there's the rules, and it's a strength. However, sometimes there's an outlier case, and maybe you want to modify the triggered action, and you want to adjust it, and you want some human interference there, and that's discretion, right? You want a technical committee being able to interfere with a bug or making an informed decision, and this technical committee has been elected. We saw the different examples. So we're on one end with discretion, can have human intervention. On the other hand, determinism, very clear rules, yeah, that enforce contracts or agreements or whatever the code is supposed to run by, the rules. So if we start with expediency and participation, you see some sort of spectrum of potential intervention or mechanisms that you could take in that spectrum. and mechanisms that basically reflect where you are in that spectrum. So when you're thinking of multi-signature governance and vote delegation, these are maybe two good examples to start with. So, for example, let's take multi-signature governance. So in a system that favors expediency, so speed, being fast and efficient, you will often see multi-signature governance. So a group of people having access and been trusted with voting powers in a multi-signature. So as we saw before, maybe there's a vote, someone has to enact it on chain, there will be a group of people having access to a multi-signature and enact it. Or maybe there is an emergency bug, a high security threat, you want this type of group to act fast, have access, and a little bit more power than the rest. So that's how you would use, in that case, this mechanism to have some sort of hedge in case something bad happens. So yeah, Polygon, for example, in December 2021, somebody reported directly to their security council that there was a threat, and there was $24 billion at threat because of a bug. They didn't report that publicly, but the council was immediately informed. And if they didn't have this mechanism to close that threat, 24 billion would have been gone. But that, thanks to this mechanism, they could quickly patch it up and save that and close that vulnerability. Just here in this case, expediency made sense. Then on the other hand, you have vote delegation. Look back, that's kind of plus minus in the middle. It's kind of a compromise between participation and expediency. It combines both a little bit. So in this case, you still have participation, right? So you have people that still get to have influence by delegating their votes to someone they trust. So this is also a way to do it. So you are a little bit faster because you centralize votes. You still allow everybody to still have impact and decide for themselves who they, refer and delegate their votes to. So it's kind of a compromise between the two ends of the spectrum in this case. So if I don't have time, I delegate, I get to still have influence. And the system can act still a bit more faster in this case. Polkadot, for example, has delegated acts, and I think Cardano also. This was one kind of trade-off situation where you have to think of what could be a mechanism, how could you find the best combination for you to hedge yourself, but also benefit from either speed or participation and community focus. You have to decide also what you're standing for. Are you community focused? Do you want to be fast? Are you more like a transaction business? Depends, right? What your values are. The second one is the tension field between immutability and adaptability. So on the one hand, immutability, you have minimized governance because, it's binary, you have your encoded rules and hardly to be changed, right? On the other hand, you are super flexible, adaptable, you can immediately adapt to everything. But probably a lot of governance involved with that, because if you can debate everything and if you can vote everything, that means a lot of talking, a lot of, proposals, a lot of changes, also takes a lot of energy and time. So let's go through some examples. So there's blockchain constitutionalism. So optimism, for example, is an example. They are very adaptable on the spectrum, but you can keep some immutability or some less adaptable aspects to yourself. So you can have some core values that are not so easy to be changed. And what they did was they came out with core values and a constitution in the beginning, and they had everyone who bought token sign up for that. Like, you agree with our constitution when you buy in. I don't know how they do it now with secondary markets, actually, but generally the idea was they reinforced the idea of this is our main constitution or values. This is not easy to be changed. And you could hold this up with higher thresholds. So in order to really make a change, maybe you would need 70% of people actually voting to change that. So similar like the democracies we know, right? In the US, changing the constitution, not so easy. Higher threshold, but changing smaller things, day-to-day things, easier. So you could approach your DAO in this way too, right? Being very flexible, adaptable in many things, but then have core values that are not so easy to be changed. So that would be constitutionalism. Yeah, so yeah, if your community wants to change something desperately, they can still do it, but it's a bit difficult. And then there is improvement proposals. So for example, there's like Bitcoin improvement proposals or Ethereum improvement proposals. Still, this falls on the adaptability side. You can propose any improvement and discuss it. And this approach kind of originates from the open source culture. Yeah, we saw big changes happen, for example, with forking protocols. It's not ideal. It's a workaround. I mean, probably there's a better way for it. It's not intended, but you can do it if you have to. So, yeah. I mean, we had the Ethereum forks and the Bitcoin forks. Yeah, the next one is determinism and discretion. So determinism is basically the outcomes are automated, rule-based, and enforced by code automatically. There's no human judgment involved. It's very deterministic. And discretion is the other end. You rely more on human decision-making and interpretation, subjective judgment. So these are more the political decisions. Do we undo the bug? Do we release the funds? Or do we just stick with the code of law, the rule, and stay on that side of the spectrum? And we're like, that's it. And that's a philosophical decision or a political decision you have to make. Where do how does your system handle these things? There's different approaches to that. I think we had this example before, Proof of Humanity. I mean, now I know that they failed, but still, they were a good example of combining the best of both worlds. They were kind of in the middle. So on the one hand, it was about verifying the proof that you really exist as a person in order to access either, I don't know, your voting rights, or maybe, how do you call that, universal basic income. In these kind of examples, you want to make sure that a person gets that income only once, right? So you want to prove that someone exists, and as Primavera said before, there were videos involved and judges looking into it. So there are a lot of human intervention and humans verifying someone is real, but then also the code enacting certain aspects of it. So there's a jury review, but also code enforcing it automatically once there was a feedback from a human in between. And this was very balanced out. So this is a case in terms of arbitration where they combined both equally. It's very balanced out. I'd love to hear why they failed later, but yeah. So that's an example of that. And then there's on-chain signaling. So we heard about Bitcoin before and how they forked, and the chain was never intended to have governance. It was supposed to be immutable and code as law, up until there was an unintentional block created and people were like, okay, we are having a split here, which one are we agreeing on? And that's when it showed that the community still was able to come together and signal on the blocks with small numbers and figures and codes, actually bits, that they're supporting one over the other. And this was counted in their dashboards, monitoring these things so they can coordinate. And ever since this had happened, and I will say it's an unintentional workaround, question is how decentralized, there is still this human, it's not completely a DAO anymore. Maybe it's just a decentralized organization rather than a decentralized autonomous organization. So there is influence now, and that changed a bit the character of Bitcoin, the fact that this is possible. But yeah, people found ways to coordinate. They always do. And then there's off-chain voting. So then we talked before about snapshots, allowing for off-chain voting and basically delivering polling and voting outcomes without actually enacting it and enforcing anything on blockchains. They're basically like a signaling tool, right? And blockchains defer to listening to it because, of course, they build trust with their community. Yeah, so many DAOs use it and trust it, and it's been widely spread. Yeah, you can propose decisions on it. You can vote using token-weighted systems, so one token, one vote. And you can do this all without gas fees. Yeah, it's convenient, it's fast, it's one way to handle your voting without having to maybe do everything on chain. And the problem here is always, though, you need a human enacting it on the blockchain. You need a multi-signature doing it because it's separate. So it's convenient, fast, and highly developed, but it's also where determinism ends and discretion begins because you need the human intervention to enact it. It's a trade-off. So, yeah. Do you need the example? Yeah. So, Snapshot gives the appearance of determinism, but really relies heavily on human interaction. You can't implement anything without that. It's just basically showing the sentiment, but has no power to implement it. So this was just some ideas and some approaches of some projects, kind of navigating the tension field between different parts of the spectrum. What you definitely, and we recommend you always keep an eye on, is having a system that is resilient. Keep the capacity to be able to adapt over time, because there will always come a problem across. So you also want to make sure you're having a robustness in your system, the ability to maintain core functionality under many different conditions. So maybe not too centralized. And yeah, that's kind of the gist of that. So to recap shortly, we've been between expediency, so fast systems, and broad community involvement. You have to find a good balance for strong flavors in these kind of categories. One way could be the option to slash back bad actors if you're on that end with expediency, to protect heavy. Yeah, if your project is heavy on the expedient side, you would want to have an option to slash actors. If you're heavy on the participation part, and you're engaged very much with your community, you may want solutions for situations that need speed. So for a tech bug, that would be maybe the added salt in your combination. If you're in between immutability and adaptability, nothing can ever change if you're on the immutability change. And we saw with the DAO hack that there are situations where you want to go around that. Yeah, you can always divert back to a fork, but it's probably not the best mechanism to go about it, and probably you would lose some funds. And then on the other side, yeah, optimism has its own approach. So if everything is adaptable, and if you can change everything, you maybe want to have at least a constitution, at least some ground rules that are not easily changed. Oops. Okay. So yeah, and the last thing maybe to take with you is embeddedness or disembeddedness with legal entities, so the real world. So you want to consider, do you build up legal entities? How do you interact with the real world? Do you have a foundation? Do you have an LLC? Yeah. And as the more you come embedded, it makes it easier to work with regulators, no matter where you are, or to open a bank account, distribute grants, whatever you want to do. It makes interaction easier. So you can't really build a DAO completely ignoring the regulatory world you're moving in. Yeah. So no system is ever fully disembedded. You will have to somehow be on the more embedded side to interact with the real world. And you're not untouchable if you ignore it. It can still basically touch upon you. Yeah, and it's a strategic design choice to be embedded, so you want to do that. Bottom line, there's no perfect way to build blockchain governance. We have talked about all 6 different kinds of spectrums and trade-offs. all of them should somehow find a balance in between. You have to find your own balance in that sense. Always strive for, yeah, some resistance and resilience in your system, and make sure you can adapt and also be resilient to difficult situations. Yeah, keep strong flavors, stick with the metaphor, and balance them out, and also definitely consider your embeddedness in the legal system you're moving in. You can ignore them, but they won't ignore you.
So this is a lecture that is designed to help us really move forward with the professionalization of blockchain governance, because the space is like 10 years old now, and we have seen over and over again that governance is a super important aspect of what makes a system survive or not. Like, there are all of these projects with amazing tech and a lot of support, and then they fail because of governance issues. And this is something, I mean, it has to do with a few different things, but one of them is that there's just not a lot of competency when it comes to blockchain governance, the blockchain governance skill set. So we want to kind of operationalize this and create a small roadmap on how to get better. Like, this course is part of it, but there's more. There's always more. So we have this huge talent gap. Largely, I mean, in the beginning, it was really because a lot of the technologies that we're building were not trained politicians, and there were this kind of, we had this new cool tool of game theory and token incentivization that took us a really long way, but not all of the way. So we have a lot of systems that are really good at incentivizing in certain areas, but not in, you cannot incentivize a whole collective in these, just with these tools. And there's also like more practical things, like there's not a lot of professional pathways. You don't really get paid for this kind of stuff. There's no formalization, frameworks, best practices. The cookbook is kind of a hack when it comes to best practices, because it really just shows you that depending on how you design the system works differently, and all of you want a different governance design for your system. Like, not all of you will need really, really, really intricate governance systems like Polkadot.OpenGov. It's very sophisticated, but if you just have a simple blockchain service, you will not need this level of governance. So just be aware that you can really choose your own level of involvement, but it is something that needs to be thought about in advance, because otherwise you don't really have a choice, unless you want to hard fork, which is not the ideal choice for most projects. So we have this need, right? So to professionalize it, we're doing this thing, and we're also developing more content, which I will present a little bit further. It's quite straightforward, and it's a suggestion that is in process. So please, if you have at the end suggestions or roles and qualities that you want to bring forward, please do. So to create this competence framework, we first have to understand what we mean by competence. And we mean these three different things. So you have the knowledge, which is the concepts and the matter in your mind, I guess. The skills, which is the capacity that you have of executing. And then mindsets, which is more the approach that you take to solve the different problems. And we've identified these different ones when we've been in conversation with former students and also people that are working in blockchain governance a lot, that these are some areas of expertise that are needed for healthy governance systems. So some of them are pretty straightforward, like technical proficiency you need, because otherwise you cannot implement the mechanism designs that Natalie just spoke about. And like legal and regulatory literacy is also another one, because you are somehow existing in a legal framework, and you need to have a method on how to navigate that somehow. There's one that's a little bit underdeveloped, which is this distributed community leadership, which is something that has been notoriously difficult in on-chain systems, because you don't want to have a leader, but somehow people end up being leaders, and they have disproportionate amount of power that can lead it in different ways. So to have something to counterbalance this is important. These are just going into the clusters, and I don't want to go into them too detailed, but I think the most interesting one to highlight is that they are all different mindsets. So in a way, they're all different people, or all different kind of competencies inside people. So if you have a Swiss Army knife brain, you can encompass all of them, but not a lot of people have. So it's really something that you need a team for. So this one, which is the fundamentals, which we are teaching you today, all of you, are this just to understand the core theories, models, and discourses, and to be able to communicate and understand why something is designed like this and not like that. Technical proficiency, mechanism design. So in the technical proficiency, you do really want an engineering mindset, because otherwise it's very difficult to implement any type of blockchain governance, etc. So this is the idea of like these identified clusters and skill sets. And I want to, not here, but so how do you build this kind of expertise that we need from all of these different people? So we had this proposal once, which is like, do we need a chief governance officer, because it is such a large area, and to steward a whole community, as to steward a decentralized community, you could really use some very specific skill sets to push this forward. So maybe we can do a simple raise of hands, like who thinks that we would want or need a CGO? No one. One. So we would like to propose that, in contrast, you can't really own governance. I mean, if then you're just an almighty ruler, which is something that you don't want in general, and especially not in decentralized systems. So we want to underline that there is this like distributed capability of the whole ecosystem as a total, and that you need all of the different people inside of the ecosystem to basically be active citizens and like active participants, and to improve their skill sets and their entanglement, like their will to want to be into the ecosystem and to contribute. So it's like the governance capability of an ecosystem, where a lot of projects fail. So we have, yeah, it's this cross-functional collaboration, shared responsibility. So we were playing with the idea of identifying the different roles, like as a CGO. If we scrap the idea of having a CGO, instead, what do we have to create this accountability and expertise in an ecosystem? And these are some that we identified. So some of it is governance researcher, which is slightly similar to what the Web3 Foundation is doing, but they're not doing that much research into the governance system, just like into the tech. But I still think it's a quite nice design to have this one instance that is focused on research, and then another one that is focused on implementation. You need some mechanism designers, some compliance experts, some stewards, and some educators to push forward. And there was one question before, which was about how to have a career in blockchain governance, which is a good question. Like right now, there's no clear pathways for it. But there's one nice example from Tommy Enekel, Alice and Bob, who has done a really incredible job in the Polkadot community, just being like an overwatcher of what goes on, and then collecting the data and presenting it so that it's easier to vote on proposals. So he's basically been a political information hub for OpenGov, and he became such a valuable member of the community that he got funding to create his own institute called OpenGov Watch, which is focused only on this. So like if you are a very active participant in these decentralized systems, you really have the opportunity to grow like this, right? And this is just some overview of some things that are out on the World Wide Web. But the Twitter thread is quite interesting, because it is this why have DAOs failed one. And it's a lot of people having these very deep democratic discussions of like why their coordination experiments didn't work out. And it's a really interesting read. And as I said also in the beginning, this kind of like this, to have good governance, it's something that we have experimented with now for 10 years. And it's clear that it's something that we need, but not something that we know exactly what to do or how to do. And it's you need both of the on-chain expertise and the off-chain expertise, and then the opportunity to combine the two. And it's just a human coordination experiment, right? But we have a whole new avenue, like we have a whole new frontier where we can do this human experimentation, and it is blockchain governance. And if we experiment with it right, then we also have a really cool opportunity to govern our technologies in a much, much better way. And then in extension, to govern how our societies govern the technologies in a much, much better way, which is something that the world agrees we really need. So it's an important topic, and I know that you think so too. And there's a lot of resources out there from Blockchain Gov, but also from others. And I think that's the end of the first bit of the day.
So this morning was more like developer and engineer friendly. This afternoon is more policymaker and regulator friendly. So again, please intervene at any point if you want extra information on anything I'm going to talk about. So yeah, basically, regulatory equivalence is a very important concept that both engineers and regulators need to be quite aware of. And the idea is basically to reflect about how can we make sure that blockchain systems do comply with existing regulation, but also how can we streamline regulatory compliance by leveraging the technological guarantees that blockchain technology provides. So in the doctrine, there is two types of equivalence. One that is maybe more commonly addressed, which is functional equivalence, and then another one which is more novel, which is regulatory equivalence. So I'm going to explain both. Functional equivalence is basically when regulators and policymakers recognize that there exists an equivalence between two separate technologies, one of which is actually explicitly covered by existing regulations, and another is not yet covered by it, but because it serves a very similar function, then the regulator can choose to extend the scope of existing regulation also to these technologies. And so examples of functional equivalence that have been quite popular is for instance, with the advent of e-commerce, all of a sudden, a lot of the wording of law were not necessarily directly applicable to the electronic context, because there were, discussion of paper documents or signature in writing. So there were a lot of words that were actually crafted at a time in which the contract was always on a piece of paper. And then with the advent of e-commerce, then it became necessary to update the legislation, but instead of creating novel legal provisions that will just expand contract law to encompass the digital realm, but also kind of create discrepancy possibly between existing contract law provision and the novel one. Instead, the legislator chose to actually declare functional equivalence, which is basically to say that the concept of written signature can actually be qualified as equivalent to an electronic signature under specific conditions. So not every electronic signature will qualify, but here is the condition for an electronic signature to be regarded as equivalent to a written signature and therefore be fitting within the same scope of regulations. So basically, functional equivalence is about applying existing legal rules to new technology that were not covered by the technology at the time of writing, but that serve an equal function. So examples in the blockchain space, there are many because, again, just like the digital internet, etc., created a necessity for recognizing functional equivalence, also the blockchain introduced many new technologies that were not thought of at the time of writing the law, and yet that serve somewhat similar purposes. So one obvious case that I guess most people are aware of here is the initial coin offering, which basically can be regarded under some condition as being functionally equivalent to initial public offering, right? There is obviously distinctions in the form, but there is similarity in the function. So on the one hand, the IPO is about issuing the share of a company, whereas the ICO is about issuing cryptocurrency tokens. So obviously, we're not talking about the same thing. The IPO is generally operated via a centralized stock exchange, whereas the ICO is operated via smart contracts, so the technology is quite different. But the IPO is also deeply regulated because of protection of the investors, whereas ICOs, as they are born as being different, because it's not about shares of a company, because it doesn't, it's not traded in the same way. As they come into being, they are not regulated. There is no existing regulation that cover those things because those things were not conceived of at the time of making the laws. And so the question is, what is the legal qualification of those tokens? And the legal qualification need to understand a few things in order to declare the extent to which it can be regarded as functionally equivalent. One is, what was the function for which the token was originally issued? And second is, what are the actual practical use of this token? So independently of the intention of the token issuer, how is this token actually used by the investors? And is this fulfilling a similar function as an IPO? And so this has led to different qualification of tokens based on the particular function that they play. On the one hand, we have payment tokens. On the other, we have utility tokens, governance tokens, investment tokens, asset-backed tokens. Those are all like a variety of possible functions that they can play. Of course, the same token might also fulfill many of those functions at the same time, which creates further complexity. But to the extent in which they do either are issued specifically as investment token, or if they are actually being used as a speculative investment, then they will fall within the qualification of securities in the same way as IPOs. And so independently of the technicality, independently of the operationality, to the extent that the function is similar and that it raises similar risk, then it will also be regarded as being functionally equivalent and be regulated within the scope of traditional IPOs shares. So what this means is that when we apply functional equivalence to the blockchain, we realize that the blockchain is a platypus, meaning that depending on how you choose to look at it, it will look like something, it will be functionally equivalent to something, but it just happened to be functionally equivalent to a lot of different things at the same time, because you just look at one part, but if you look at the whole picture, it's a whole new creature, but this new creature actually share functions that are similar to many other things. And so you can look at tokens as money, you can look at them as commodity, you can look at them as securities, and obviously the regulator of those different things will always see the similarity and the functional equivalence, and therefore will want to regulate that new asset independently of whether it is also regulated by many other entities. And so this means that regulatory compliance for blockchain system becomes quite challenging. One, because the same asset has to comply with many different regulations because of the multiple facets and the multiple function that it can inherit. And secondly, because the legal system that was designed for specific assets was actually created with a particular system in mind, which often was a centralized issuance and a centralized exchange which, because of the centralization and because of the design of those institutions, actually had quite a high degree of counterparty risk. And at the same time, if we look at the distinctive properties that blockchain technology provides, they are disintermediated in a way that therefore do not actually raise the same risk, right? And so in some way, like the only way in which a blockchain system can actually comply with this regulation is that it needs to comply with many regulations at the same time, but also respond to specific regulatory formalities, which are difficult to actually achieve because there is no intermediary operator that can fulfill those formalities because it is a decentralized system. So even if a blockchain system wants to actually comply with all the formalities, it is quite challenging for all those reasons. So that's the issue with functional equivalence, which is it is necessary to apply functional equivalence in order to cover the scope of blockchain within the existing legal system without having to create a new law of the blockchain. But this functional equivalence, because it is too easy almost to find equivalences because the blockchain is such a versatile technology, then it creates like a very high burden to be regulatory compliant. So on the other side, we have regulatory equivalence. And so the regulatory equivalence is actually trying to shift from existing legal constraints and how they can be translated into technological guarantees. So the idea with regulatory equivalence is that instead of trying to find equivalence between two technologies that fulfill the same function and therefore should be regulated in the same way, regulatory equivalence is actually looking at what is the regulatory or policy objective that a particular law is trying to promote, and then trying to find equivalence in the way in which this policy objective can be complied with in ways that maybe do not necessarily have to fulfill exactly the same regulatory formalities, because there are equivalent manners to fulfill the same regulatory objectives. It's quite a different concept than functional equivalence. Functional equivalence is about expanding the scope of regulation. Regulatory equivalence is about expanding the scope in which regulatory compliance can be achieved. And usually they come together because as functional equivalence takes territory, then regulatory equivalence system needs to be enacted in order to facilitate compliance within those new territories. So in Europe, at least, there is like regulatory equivalence is often described as principle-based regulatory approach, which means that it is about what is the principle of the law. And if we find ways that comply with that principle, like the law is not saying this is how you need to fulfill the regulatory obligation, but it says this is the principle that needs to be respected, and then as long as this principle is true, then it's considered to be compliant. So in the case of ICO, for instance, in the same way as ICOs can be regarded as specific asset based on their function, it is also possible to imagine regulatory equivalence approaches to regulatory compliance in the ICO model. And the baseline with the principle-based regulation is that the same risk has to be regulated in the same way. But of course, if we change the degree of risk, then we also can change the degree of regulatory burden. And so to the extent that an ICO actually poses the very same risk that an IPO is posing, then obviously they should be regulated in a similar way. But if we actually manage to reduce the risk because of some technological guarantees that can be added, which cannot be implemented in an IPO, then the risk decreases, and therefore potentially the regulatory burden can also decrease. Examples of how we can reduce the risk for the investor in an ICO is the escrow system. So implementing a system in which tokens get disbursed upon the achievement of specific milestones, so that the investors are are staking their funds. So we know that the funds are locked somewhere, but they only get disbursed if the specific milestones are delivered. So these protect on both sides. Same thing with like the locking or the vesting period, where you can ensure that there is like a protection because the token cannot be immediately dumped with speculative practices. There is also the possibility of creating a speculative capping by basically continuing to issue a supply of token whenever the market price reach a particular level, and defining all those algorithmically through a smart contract, so there is not like an arbitrary decision to just issue more tokens. So those are old mechanisms that few of them have been implemented, but some experiments have been done. But of course, this is like a technical guarantee way to actually provide protection for the investors and for the issuers. But of course, if it is not recognized by the regulator as being regulatory equivalent, then it creates lower risk, but it doesn't, the creation of this lower risk doesn't translate into a lesser regulatory burden. And that's where regulatory equivalence require the intervention of the regulators to recognize and to actually endorse those practices as being aligned with the policy objectives, and therefore also dictating that this will lead to a lesser regulatory burden. And this becomes a way actually for regulator to exert pressure on the technical design of a particular system, because if I know that the regulator has recognized those particular practices are regulatory equivalent, then I also know that I will benefit from a better situation for regulatory compliance, and therefore it will incentivize people to design into the system because of the legal benefit that they get from that. Other example, those are like mostly examples that were used by the cryptocurrency exchanges. So it's like proof of reserve, which is an like blockchain-based and cryptographic-based system in order to demonstrate that the cryptocurrency exchange is not issuing more token than their actual reserve. So it enables a real-time auditing that can be verified by every individual without having, therefore, to theoretically comply with all the auditing requirements, because it's actually verifiable directly by every user. Same thing with the keyless wallet that remove the custodian aspect of the funds, and therefore it removes the counterparty risk that the centralized entity usually have, and therefore, as a consequence, should also reduce the burden that those counterparties are having, because they don't have the ability to actually move the funds of their clients. Many other examples exist, so real-time audits, automated reporting, the guarantee of execution because of the smart contract, etc. There is also like many mechanisms of like creating proof that a particular process has been done by actually hashing information on a blockchain on a recurrent manner, so that people can ex post verify that something had been done. The use of multi-signature in order to do controlled expenditures, which usually require a lot of oversights in a corporate setting. Certification that data has not been manipulated. For instance, like if there is the case of like, I don't know, like health data or like testing, and then by storing the particular hash of or the state of a database on the blockchain, when there is a verification later that comes, the entity can prove that the database has not been manipulated, because what they show is exactly what has been hashed on the blockchain. So this enable like mechanisms by which the usual very expensive processes of auditing and reporting, etc., can be streamlined just by creating a few specific technological guarantees, which again need to be recognized by the regulator as being valid regulatory equivalent techniques.